Okay, dear students, now we are going to discuss about number of electrons in the conduction band. Okay, so number of electrons is represented by small letter n or n suffix e. Okay, n suffix e. So now I am going to use the term n. Okay, so this is the diagram for the energy level diagram for the intrinsic semiconductor. Okay, as you know well, so the lower energy band is called valency band, the upper energy band is called the conduction band. Okay, so the valency band here the limit starts from minus infinity to EV. What is EV? EV is the energy and top energy of the valency band or energy of the top of the valency band. Okay, when we come to the conduction band, the lower limit is EC, the upper limit is plus infinite. So what is EC? EC is the energy of the bottom of the conduction band, bottom of the conduction band. Okay, so now in between these two I introduced one more energy level, that is called Fermi energy level. So what is that? E suffix F. Okay, EF is the Fermi energy level, Fermi energy level. So what is this Fermi energy level? That is, when we discussed in the particle in one dimensional box, this is the diagram for that. So it consists of large number of energy levels. N is equal to 1, N is equal to 2, N is equal to 3, like that. So many energy levels will be existing in the case of particle in one dimensional box. So for example, at T is equal to 0 Kelvin, when temperature is equal to 0 Kelvin, that time, so in the first energy level 2 electrons will be there, second energy levels 2 electrons, like that all the electrons will be occupying the energy state. Okay, energy states. So now when we see at T is equal to 0 Kelvin, up to here only the electrons are filled. By seeing the diagram we can differentiate. Okay, so what is that? N is equal to 1, 2, 3, 4. So this energy state, the last energy state up to which the electrons are filled is called Fermi energy level. Okay, up to which the electrons will be filled, that too at T is equal to 0 Kelvin. So this is the Fermi energy level. In case of intrinsic semiconductor, the Fermi energy level exactly lies in between the valency band and the conduction band. So that EF can be written as EF is equal to EV plus EC divided by 2. EV plus EC divided by 2. Okay, this also we will solve in the next class. Okay, so now our duty is to find number of electrons in the conduction band. Number of electrons in the conduction band. So what I am going to do, what is the steps we are going to follow to find the number of electrons in the conduction band? First, what I am going to do means, this is the such a big energy band. Okay, so that finding for the whole band is very difficult. Finding the number of electrons for the whole band is little difficult. That's what. First I am going to consider one energy range. Okay, within this two range energy I am going to find the number of electrons. Later on I will do for the whole band. Okay, so for example, this energy is represented by E and this one will be E plus DE. Okay, so within this range I am going to find a number of electrons. So within the range the number of electrons is represented by Dn. Okay, for the whole band the number of electrons is small n. Within the small range of energy interval E and E plus DE is Dn. So Dn is equal to Z of E into DE into F of E. Okay, actually in these two terms we are having Z of E into DE and F of E. Okay, let us discuss one by one. First, this one I am considering equation number 1. What is Dn? Dn is the number of electrons within the energy range E and E plus DE. E and E plus DE. Okay, so for the whole band I have to find out. So what I have to do? For the whole band the number of electrons is represented by small n. What is the limit here? The band in between EC to infinite. EC to infinite. So EC to infinite is EC to infinite and then Dn, which is equal to EC to infinite. Okay, and then Z of E into DE, that is the value of Dn. So Z of E into DE into F of E. Okay, so this is what the steps we are going to follow. This is equation number 2. Okay, so now already I said this is one term, this is the other term. Let us discuss one by one. First term what I considered Z of E into DE. Z of E into DE. What is this? This is nothing but density of energy states. Density of energy states. What is that meaning of density of energy states? Actually, as I said already, Here you see how many number of energy states available. For example, for this diagram, 5 energy state is available. Likewise, in case of this intrinsic semiconductor, how many energy states are available? That already they have derived. So direct formula I am going to consider. Z of E into D is equal to, the formula is 4 pi divided by h cube and then 2m power 3 by 2 and then e power 1 by 2 into dE. So this is the equation to find how many number of energy states available in the intrinsic semiconductor. So let us see all the terms in this expression. 4 is the numerical number, pi is the constant, h is the Planck's constant, again 2 is the numerical number, m is the mass of the electron, m is the mass of the electron, and E is the energy of the electron, that too kinetic energy of the electron, and D is the derivative term. Okay. So now here I am going to do 2 modifications for this. What is the 2 modification? First modification is m is equal to me star. What is this me star? That is effective mass of electron. Effective mass of electron. What is this effective mass of electron? Which is nothing but, in case of the material, all positive ions will be uniformly arranged, but the electrons will be moving everywhere. The electrons will be moving everywhere. The potential energy of the electron is having different nature. What is that? When the electron comes closer to the positive ions, that time the potential energy will be very less. But in between the 2 positive ions, the potential energy will be increased like this. Okay, so this is what the periodic potential. That means the electron is having periodic potential when it comes closer to the positive ions. That's what. Instead of using normal mass, we are going to use effective mass of an electron. This is the first modification we are going to do. And the next modification is E. What is E? I said E is the kinetic energy of an electron. So now we are talking about the electron. Okay, the electron is present here. What is the energy of the electron? E. Okay, so now what is the potential energy of the electron? EC. Why? Because the electrons will be at rest in the bottom of the conduction band. The electrons will be at rest in the bottom of the conduction band. So EC is the potential energy. So what is the general formula? Total energy is equal to potential energy plus kinetic energy. Okay, so now we are talking about this kinetic energy only. Total energy is E minus potential energy. What is the potential energy here? EC, which is equal to the kinetic energy. So that instead of E, I am going to write E minus EC. I am going to write E minus EC. So this is what the second modification. This is the second modification. First one is m is equal to me star, and the second one is the effective E minus EC. Okay, these 2 modifications I am going to do in this equation. This I am considering equation number 3. Okay, so let us go to the next page to substitute this value. Instead of m, I am going to write me star, and instead of E, I am going to write E minus EC. Okay, so let us go to the next page. So now where we are, Z of E into dE is equal to, what is the formula now? 4 pi divided by h cube. Okay, instead of m, I am going to write me star whole to the power of 3 by 2, and then instead of E, I am going to write E minus EC whole to the power of 1 by 2 into dE. So finally we got the Z of E into dE value is this much. So this is equation number 4. Okay, first term we completed the discussion. What is the next term? F of E. What is meant by F of E? F of E is nothing but Fermi function. What is this? Fermi function. What is the Fermi function? That explains the probability of occupancy of the electrons. How many electrons are present? Okay, probability of occupancy of the electrons. That is called Fermi function. This Fermi function I am going to write with the help of Fermi distribution function. Okay, so according to Fermi distribution function, F of E can be written as f of e can be written as 1 divided by 1 plus exponential of e minus ef divided by kt, e minus ef divided by kt. So what is this? This is Fermi function, nothing but probability of electron occupancy, probability of electron occupancy, right? So now we are going to discuss according to our condition. What is that? So already we have seen, once again I simply draw this diagram. Fermi energy in the middle, okay. We are talking about the conduction band. So conduction band is here, this is EC, this is infinite. So we are talking about the electrons which is present in the band of, in the conduction band. So here E minus EF, E is the highest value, EF is the smallest value. So E minus EF, E minus EF, okay, will be very much greater than KT, very much greater than KT. What is K here? K is the Boltzmann constant and T is the temperature. So in this case, E minus EF, highest value minus the smallest value will be very much greater than KT. So if I am taking this KT here, E minus EF divided by KT is also very much greater than 1. Okay. So KT if I am taking here, here 1 will be existing. Next step, if I am considering exponential of E minus EF divided by KT, okay, which is also very much greater than 1. Okay. So that is the reason, now you see the denominator part, 1 plus exponential of this term. So this second term, exponential of E minus EF by KT is very much greater than 1. So along with this, if adding 1 is meaningless, that's what I am going to do is neglecting, here I am giving this equation number 5, okay. So neglect, okay, 1 from denominator in equation 5. So what will happen now? In equation 5, the denominator 1 will go. So what will be remaining? 1 f of e is equal to 1 divided by exponential of e minus ef divided by kt. E minus ef divided by kt. So this is equation number 5. Okay. So now we have two equations. One is z of e into dE and another one is f of e. Okay. So these two equations, that is equation number 4 and 5, I am going to substitute in equation 2. So what is that equation 2? Let us see once again. So equation 2 is here. What is equation 2? N is equal to EC to infinite, Z of E into dE and F of E. Z of E into dE from equation 4 and F of E value from equation 5. I am going to substitute here. Okay, so let us go to the substitution part. So now, what is that? Second equation becomes, okay, N is equal to, what is the integration part? Limit, lower limit is EC, upper limit is infinite. What is the Z of E into dE from equation 2? 4 pi by h cube, okay, 2m E star whole to the power of 3 by 2, and then instead of E we have written E minus EC whole to the power of 1 by 2 into dE. This is from equation 4 we have written. And what is f of E value? 1 divided by exponential of E minus EF divided by KT, right? This is what the expression we substituted. Now this dE derivative part I am going to write in the last of this expression, and moreover whatever the constants present over here, everything I am going to take out of this integration part. So what are the that is constants? 4 pi divided by h cube is the constant, and then 2m E star whole to the power of 3 by 2 is also a constant. Okay. After that I am going to introduce to the integration part EC to infinite, which is remaining now E minus EC whole to the power of 1 by 2. Okay. dE I am going to write at the last. Next 1 by exponential of E minus EF divided by KT into dE, right? Okay, so next step what I am going to do is 1 by exponential. I am going to take this exponential to the above. That means 1 by e power a is there. If I am going to write like this, e power minus a. So accordingly I am going to take this term to above. to the numerator. So what will happen now? 1 by exponential of E minus EF divided by KT is there. If it is going up, the sign will change. Exponential of plus E will become minus E. Okay, minus E, minus into minus will become plus. EF divided by KT will come. Okay, so divided by KT, right? Divided by KT will come. So now what I am going to do is 4 pi divided by h cube, okay, and then 2m e star whole to the power of 3 by 2, okay, integration EC to infinite, okay, E minus EC whole to the power of 1 by 2. This term is going up, so that exponential of minus E plus EF, okay, divided by KT into DE, divided by KT into DE. Okay, what is the next step? Even EF is also the constant. Okay, so here I am going to use another equation, that is exponential of A plus B. Exponential of A plus B can be written as exponential of A into exponential of B. Okay, so we can write like this. Here A is nothing but minus E by KT. B is nothing but EF by KT. Okay, so how can I write exponential of minus E plus EF? Okay, so we can write KT like this. We can divide this. Okay, so that I can write exponential of minus E by KT into exponential of minus EF divided by KT, right? So this, plus EF by KT. So here this plus EF by KT I am going to take out of this integration part. So what is the step? 4 pi divided by h cube, okay, 2m e star whole to the power of 3 by 2. What is the term I said? Exponential of, okay, EF divided by KT, okay, and then integration EC to infinite. What is there inside? E minus EC whole to the power of 1 by 2, and then exponential of which term is remaining now? Exponential of minus E by KT into DE, right? So this is what we are having. So this I am considering equation number 6, right? The next step is we have to solve this integration part. To solve this integration part, 3 things. Okay, first one is I am going to consider, okay, this part as x. I am going to consider this part. Which part? This E minus EC is there, no? That I am going to consider it as x, so that I can able to solve this. And what is the lower limit? Lower limit is easy and upper limit is infinite. So that is our next step. So let us go to the next step. I'm going. The next step is to solve the integration part. So what is there in the integration part? Let me write this. So is it of? Sorry. So n is equal to 4 pi. Okay, 1 minute. Let x is equal to E minus EC. X is equal to E minus EC. So what I am going to do? I am going to consider only E. So E is equal to, E will be there in this side. So x plus EC will come. Right, this minus EC will go that side, so E is equal to x plus EC. If you differentiate this, E become DE and x will become DX. EC is the constant, so that it will become 0. So instead of DE, I can able to write DX. That is the first change I have done, first part, okay, over. Next we have to change the limits also. What is the limits I said? So first limit is EC, okay, lower limit, and the next limit will be infinite. So when the energy is equal to this much, what will happen to x? So when energy E is equal to EC, what will happen to x? So when energy E is equal to EC, when energy is equal to lower limit, that time you substitute here. X is equal to, the formula is the same formula I am writing here. X is equal to E minus EC. Okay, what is the E value now? We are considering EC. So X is equal to EC minus EC. So what will happen now? X is equal to 0. X is equal to 0. So now the lower limit EC is changed to 0 now. Okay, and then we are coming to the upper limit. What is the upper limit? Infinity is the upper limit. When energy E is equal to infinite, what will happen? Okay, let us discuss that part. So the same equation I am writing here, x is equal to E minus EC. Okay, so x is equal to, instead of E I am going to write infinite minus EC. So infinite minus anything will become 0 only, so that x is equal to infinite. So x is equal to infinite. So now the lower limit is 0 now, the upper limit is infinite. The E minus EC we consider it as x. Okay, substitute all the values in the above equation. So what is the above equation? N is equal to 4 pi divided by h cube. Okay, 1 minute. 4 pi divided by h cube. Okay, 2 m e star whole to the power of 3 by 2, and then exponential of EF divided by KT. These terms are outside the integration. Then we have to start the integration part. So what is that? Here already instead of, okay, I will write this integration. Lower limit is 0, the upper limit is infinite. E minus EC is equal to x, so it will become x power 1 by 2, and then exponential of minus E divided by KT is there. So minus E plus E is equal to this much, so minus E is equal to, here I can write E is equal to x plus EC. Okay, so minus E is equal to minus x minus EC, right? So here I can write minus x minus EC divided by KT into, instead of DE I am going to write dx. Okay, this is what the term we are having. Right, here you see minus x minus EC by KT. Again the same formula of exponential of A plus B is equal to exponential of A into exponential of B. According to this, we can write our expression also. So what is our expression? Exponential of minus x by KT minus EC by KT. Okay, which is equal to, how can we write? Exponential of, okay, exponential of minus x by KT into exponential of minus EC by KT, right? So now the same thing I am going to write here, 4 pi by h cube 2m E star whole to the power of 3 by 2 exponential of EF by KT is there, right? So this minus EC by KT I am going to take out, exponential already is there. So how I am going to take minus EC by KT? Okay, EF minus EC divided by KT. Okay, and then what is there in the integration? 0 to infinite x power 1 by 2 exponential of minus x by KT into dx. Now you see inside the integration there is no energy term, everything only x term is present. To solve this integration part I am going to use gamma function. So what is that? Using gamma function, what is the gamma function formula? Integral 0 to infinite root x into exponential of minus ax into dx is equal to 1 by 2a into root of pi by a. So this is the formula already existing in gamma function. So here compare this to equation, root x, x power 1 by 2, both are same, exponential will be same, minus also same, a into x. Here what is the value of a in this? A is equal to 1 by kt. A is equal to 1 by kt. So in the result, if you substitute A is equal to 1 by kt, we can get the result for this integration part. So now let us go to the next step. So now what is our expression? Integration 0 to infinite, okay, root x into exponential of minus x by kt into dx is equal to, what is the answer? 1 by 2a. What is a here? 1 by kt, right? Into root of pi divided by a. A is nothing but 1 by kt, okay? So this kt will go up. So how can I write? Kt by 2, right? And then this kt again going up. So in the root of pi kt, right? So here I am going to solve this. What is this? This is kt power 1 by 1, kt power 1, here 2 is there, here pi power 1 by 2, and then kt power 1 by 2, like this we are having. So kt power 1 and kt power 1 by 2. How can we write? Here k power 1 and kt power 1 and then kt power 1 by 2. How can we write? The powers can be added together. The powers can be added together. So how can we write? Which should be equal to kt power 1 plus 1 by 2. So that it will become kt power 3 by 2, right? So according to this, I am writing kt power 3 by 2 and then pi power 1 by 2 whole divided by 2, right? So this is the answer for this integration part. Okay, so now for this integration directly we can substitute this equation. So what is the final result we got? N is equal to 4 pi divided by h cube, okay, and then 2m e star whole to the power of 3 by 2 and then exponential of EF minus EC divided by KT. Okay, here only the integration starts. For this integration, what is the answer we got? KT power 3 by 2 and then pi power 1 by 2 whole divided by 2. Okay, so this 2 and this 4 can be cancelled, so 2 will be existing here. So now this 2 I am writing outside, and then see here pi power 1 and then pi power 1 by 2. So same thing, pi power 1 into pi power 1 by 2, which can be written as pi power 3 by 2, right? So kt is also having power 3 by 2, pi is also having the power 3 by 2, 2me star is having the power 3 by 2. So all the terms I am going to write within a single bracket of the power 3 by 2. So 2 as such, 2 can be written, and then pi is also having the power 3 by 2. So pi, okay, and then me star, okay, that is also power 3 by 2 kt. See, all the terms are having the power 3 by 2. So here I am going to include the h also. Actually h cube is the answer, right? I have to get h cube. When I am including this h cube within the bracket, how can I include? Now listen, actually I need h cube. So for example, h square 3 by 2. Okay, I am including h square within this bracket. The square and the square will be cancelled. I can get h cube. Okay, so this h cube, how can I write? H square whole power 3 by 2. So here h square whole to the power of 3 by 2. So if I am removing this, square will 2 will be cancelled. Outside it will become h cube, right? And then exponential of EF minus EC divided by KT. Okay, so this is the number of electrons within the conduction band, number of electrons in the conduction band. So this is the final result of number of electrons in the conduction band. Okay, so now our derivation part is completed. Okay, so this is number of electrons in the conduction band. Once again I will repeat, n is equal to 2 into 2 pi me star kt divided by h square whole power 3 by 2 and then exponential of EF minus EC divided by kt. So this is what our final result. Okay, thank you.